Hello everyone. Today let's solve the problem queries. So here you can read the entire question. So I'll just summarize the question so that it is easy to understand. Right. So just give me a second here. So what the question states here. So we are given an integer sequence. So we are having the sequence of integers and set of queries. So these two things we have to keep in mind. We have sequence of integers and set of queries. We can perform three of the operations. First one, what we are having sequence of integers and this one, set of queries. These two things we are having. And we are having, so we can perform either of the three operations. So let's see what are those three operations. I'll just come here. First one. So first one is increase the number of sequence by given value. So increase number of sequence by given value. So increase the number of sequence. I'll just consider sequence SQ. So increase the number of sequence by given value. First thing. Second thing, decrease the number in the sequence by a given value. Only if the result is non-negative, then we are decreasing the number in the sequence by a given value. First thing was increase the number of a number in the sequence, right? And a number in the sequence by a given value. Here this one is decrease number in the sequence. So this one is not off actually. This has to be in. Increase number in sequence, decrease number in sequence. And also finally, the third one is some numbers with the given range, but only those that are equivalent specified within the modulo. So sum the numbers in given range. So sum numbers in given range. I'll just check GR in the given range. So these three things we can do. So we are given integer sequence and we are given set of queries. We can either perform these three things as I have explained. Nothing but increase number in subsequences, decrease number in subsequences, also some numbers within the given range. So but only those are equal and specified modulo, right? So let's see how can we do this. Let's see the approach. Let's discuss the approach and let's implement that one in the code. So initially, as usual, we'll be going with the input reading or input handling. So here first step will be input reading or the input handling. This is related to only the input taking, right? So we are writing the code using Node.js or the JavaScript. So by this time, you'll be knowing the input reading and input handling. This is same for most of the problems. So while we write the code, you'll get it. Let's come to the core logic. Nothing but in this particular problem, we will be going with the segment tree implementation. So we'll be going with the segment tree here. Why we will be going with the segment tree basically? Let's discuss the same. So first, segment tree construction. We will create the segment trees for different modulo classes from 0 to this one, right? Modem. So each tree stores numbers that satisfy the corresponding modulo condition. Each tree will store the numbers that satisfy the corresponding modulo condition. So the reason we are constructing the this one, a segment tree, because we have to store the numbers that satisfy the corresponding modulo condition, right? So for this purpose, we'll be making use of the segment tree. This one will be segment tree construction. Second step, after the segment tree construction, what we will do, we have to update, we have to make use of the update operation as well, right? So when a number in the sequence is increased, we are having a sequence of numbers they have given. If the number of sequences is increased or decreased, right? So we can perform either of the three steps they have clearly given in the question, as I have explained in the question. When the number in the sequence is increased or decreased, we have to update the segment tree to reflect the change. So that's why we'll be performing the update operation. So again, I'm telling we'll be performing the update operation. This is the third step. After performing the update operation, what we have to do? We have to perform the query operation. Nothing but when we are asked with the sum of numbers with specific range. So sum of numbers within particular range. So suppose I'm just taking for the example 0 to n. So here when we are asked the sum of numbers within the specific range that match a modulo, we will traverse the segment tree corresponding to that modulo class. Nothing but we'll be performing the query operation. So this one updation, segment tree construction, updation and the query operation, we will clearly see this one while we write the code. So efficiency, let's come to the efficiency part. We are making use of the segment tree that allows for efficient updates and the range queries, right? Mostly we'll make use of the segment tree and the funbit trees for the range sum queries itself. So we can, this is scalable for the large input sizes. So finally, in this fourth step, we'll be getting the output and we have to display the output. For displaying the output or to output the result, so we'll be making use of the console log as we are making use of JavaScript or the Node. So this is the approach that we are going with for this particular problem. So I hope this is clear. Let's start writing the code so you will get to know this one better. So first step will be, as usual, we are importing the this one fs module to read the input. Just give me a second here. Let's start writing the code. This will be require of fs. So I'll just take const input here. We have to read, right? For that purpose, I'll just make use of the read file sync. Let's start from 0 and let's set the encoding to UTF-8. Also, let's trim this one to remove the unnecessary spaces within the input. We'll be making use of them. Also, to read the input line by line, I'll just go with the split. So I'll just make use of the regular expression over here. This will be /n/r. And finally the slash. So I hope this is clear. The next step will be we will make use of the variable to track the current input line. So I'll just give, we were taking count equals 0, right? That itself I'll just make use of C this time. So let's write the custom function to read the line of input and convert it to the array of numbers. Just make use of the custom function rnum. A read num we were making use of, I'll just write rnum. So here this will be instead of the, so yeah, I'll just consider here this one, I'll just consider this one as inp itself. I don't want to type more actually. I'll just go with split. If we are having the distinct numbers within the same line, to segregate between them, we'll be making use of split. Also, to convert it to the numbers, I'll just map this one and we can write in this way, plus a. This is simple. After this, we have to read the first line of input, nothing but number of elements and the modulo m. For this, I'll just make use of the destructuring operator n, m. We have already written the rnum function to read, right? Custom function. So I can just call this function over here. Next, let's read the sequence of numbers. I can simply give here, let a equals, sorry, we have to read, right? So I'll just make use of rnum again. Also, we have to read the number of queries as well. Along with the sequence of numbers, we have to read the number of queries as well, right? I'll just consider here q equals plus input of count. For count, I have considered C, right? C++. So let's initialize, let's initialize n segment tree, one for each modulo class, each of size 4 into n. So for segment tree, I'll just consider est, this one, array dot from of length, what's the length here? Length m. Also, this one has to be array of each of array what? So we are initializing a segment tree, one of each modulo class, each of size 4 into n, right? So yeah, here 4 into n, we can consider like this, 4 into n. And we will fill each value with initially 0. So I hope this is clear. So initially, as we have discussed in this one approach, let's build first. Let's build the segment tree. So instead of making use of the classic way of using the segment tree, like making use of the class segment tree, I'll just make use of the function. We can make use of the function itself, right? It will be easy comparatively. So I'll just give function build v. I'll just take 3 parameters. One is v, l, left and right. So this one is my l and r. If l, if it is equal to r, then if it's a leaf node, then we will calculate the mod class and store the value in the corresponding tree. So I can just write like this: mod class variable name. If it is a of l, module m, then we have already called the segment tree st. I have considered this one will be st of mod class, and v, this one will be a of l. So next step is else what we will do. Otherwise, we'll recursively build the left and right children. So we'll be making use of recursion here. So first we have to calculate the mid. I'll just give here let mid equals, instead of math.floor, I'll just make use of that double tilde operator. So here this will be somewhat faster compared to math.floor, right? So left plus right by 2 to calculate the mid. Next we will make use of the recursion or the recursive function. We have already we'll just make use of the build itself, right? It will be 2 into v plus l, v plus 1 it has to be, and also left we will consider, and also mid we will consider. This is nothing but to build the left child. Next we have to build the right child as well. Again I'll be making use of build. I should have copy pasted. This is fine. 2 into v plus 2, same thing. Here it will be plus 2, and mid plus 1 also r, right? So I hope this is clear. After building the left and right child, what we will do, we have to combine the results for all the modular classes from left and right children. Let's do it by iteration. So I can just consider this one. Let mod class I have considered. This one, let me consider this one 0. This mod class has to be less than m, and mod class, let's increment this one. And finally I can write in this way: segment tree of mod class, and v here. This one again segment tree of mod class. This one has to be 2 into v plus, this has to be v plus 1, and also again we have to make use of segment tree mod class of 2 into v plus. So this is one thing. So we have completed the build part. Next, what we will do, we have to, as we have discussed in the this one approach, after building we have to update the segment tree with the new value. So let's write the function update. So I'll just give here function update and take the parameters, same thing, v, l, r. Along with this one, let's consider 2 more things. One is index and another one is value. So here same thing, if left equals right, or if l equals r, then if it is a leaf node, again same thing we'll be doing. We'll update the array and the mod class in the tree. Simple. This will be a of l equals a of l plus value. So this has to be value, sorry, val. And again let me consider a mod class equals a of l modulo m. So this is fine. Next step is we have to reset all the modular class trees at this position, and we have to update the current one. First we will reset all the this one modular class trees, and then we will update the correct one. So for that I'll be making use of this is similar to the build operation itself, if you have observed. So there are certain changes that we have to make that set. So here I'll just come here, let I equal 0, I less than m. Let's increment the I here, segment tree of I v, this is equal to I mod class. If it is true, then we will be displaying a of l. If it is false, we will be displaying 0. This is fine. Else what we will do? So here I'll just come. Let's this one, make use of the mid. Instead of the method floor, I'll just make use of this one, double tilde operator. This one will be 2. So after this, calculating the mid, again we will recursively update the left or right child depending on the index this time. So this one here, where did we do this one? Here you can see the same operations, similar operation will be carrying on. So here we'll continue with basically. So if index, if it is less than or equal to mid, then what we will do? I'll just make use of the update 2 into, it has to be v plus 1 l mid index as well as value. So else, if index is greater than or equal to mid, then what we will do? We'll go with update 2 into v plus 2 for the right one. Here we are updating the left child. Here this step is what I'm writing now, what I'm typing now. This step is for updating the right child. So this has to be again same thing, mid plus 1 comma r, and we have extra 2 parameters for the update, nothing but here index as well as value. So yeah, this is fine. So this is just the pure recursion. After this one, what we have to do? After updating the children, we have to update the current node by combining the results from the left and right, as usual in the build we have carried on. So if you have observed the build correctly, this is same thing, similar thing. Basically, we are just changing certain things with 2 extra parameters, index and value, right? So this one has to be mod class equals 0. Mod class, if it is less than m, let's increment this one. We will set the segment tree of mod class p. Again segment tree of mod class. This is 2 into v plus 1. Also finally segment tree of mod class 2 into v plus 2. So this is fine. So finally what we will do here, let me come here and we'll do one thing. We'll write the function query now. So why we have to write the function query? We have to query the sum of values, right? We need the sum of value for a particular range or in a given range. We are writing the function query because we need the query. We need the sum of values in the given range that belong to a specific mod class. So let's write this one quickly. So after query, we can write the main function, right? So this is just build, update as well as the query. So I can just write in this way, function query here v comma l comma r, and let's consider query 1, query 2, q1, query left and query right I have to consider, right? Sorry, this one, ql, qr, and finally then consider mod class. So here, first thing is, if the range query is outside the current segment, then we will directly return 0. It shouldn't be outside the this one current segment. So how can I write that? So this is condition, right? I'll just make use of if query left, this one is greater than r or q, right? This one is less than l, then we will return 0. This is fine. Next, if the current segment is fully within the query range, then we will be returning the sum. Here, QL is less than or equal to L, and QR, if it is greater than or equal to R, then we will return segment tree of this one, mod class and key. What we are doing here, if the current segment is fully within the query range, means in simple terms, if the current segment is within the query range, then we are just returning the sum here. Next part is we have to find the mid as well, right? So to calculate the mid, as usual, I'll just be making use of double tilde operator. Here left plus right by 2 thing. Otherwise, we will combine the results from the left and right children. Nothing but I'll be making use of the recursive function query. 2 into v plus 1. What are the parameters we have? V, L, also mid, we have QL, QR, and finally mod class. This is one thing. Again, plus query of this one for the right one, right? 2 into v plus 2, and for the right one it will be mid plus 1 R, QL, QR, and what was one more parameter? Mod class, right? So this one will be mod class. So did I miss something here? No, right? So this is fine. So next we will process all the queries and print the result. So this will be the final step. We have to process all the queries and we have to print the results. So this one will be here. I'll just come for processing the queries. I'll just write the function PROC queries of process queries, right? Function name. I'll just take, first initially we need to store the results, right? For that one I'll just consider the empty braces. I'll just initialize the output or out to empty braces. Let's start iterating after the initialization. This will be 0 I less than queries q. Then finally let's increment the I. Next we have to read the each query. So what are all the parameters we have? So I'll just consider cmd p r finally mod. So I can just make use of the destructuring operators. Sorry, not the parameters. So this one will be input of count, nothing but C++, and we have to segregate between the distinct numbers. So I'll just make use of the split here. So after this, we have to convert the 1 based index to 0 base. We have considered 1 based index, right? So this one I can write in this way, plus p minus 1. So we are just converting the 1 based index to 0 based. So here finally r equals plus r I can write. This is fine. Next, if here we can write in this way. I'll just come here. If cmd equals plus, then we will increase the element at the index p by r. So I'll just be making use of update here 0, 0 and n minus 1, and this one will be p and this one will be r. Finally, we will output the updated value. I'll just give out. For adding, I'll just make use of the push. So finally, I can just give a of p here. Nothing but we are outputting the updated value. Else if what we will do, I can just make use of else if over here cmd equals minus. First we did for plus and now we will do it for minus. So if it is minus, we will be decrementing the element at index p by r. Also, we have to ensure that it doesn't go below 0, right? It shouldn't be below 0. So here is A of P, if it is greater than or equal to R, then we have already written the update function. I'll be making use of update 0, 0, 0, n minus 1 and P minus R. This one. This is fine, right? So after this, we have to output the updated values. For that, we have to add the values, right? So I'll just make use of, for adding, I'll be making use of push here. Push A of P within the array. So this is fine. What we are doing here, we are just outputting the updated value. Next, else if command is equal to s, then cmd equal to s, then we will query the sum of elements in the range p comma r minus 1. So this we have to remember. If it is equal to yes, then only we will query the sum of elements in the range p comma r minus 1 that are equal to mod. So here we can write in this way. Else if cmd, if it is equal to s, just give me a second here. This one I can write in this way, right? We have to just query the sum of elements in the range p to r minus 1. So to add, I'll just make use of output. Out I have considered, right? Dot push. Here I'll just consider query of 0, 0. This will be n minus 1. This will be p. This will be r minus 1. And finally, I'll just give plus mod. So I hope this is clear. Finally, we have to print the result after this step. So I'll just give here. We have to print all the results, right? So I'll just consider out. We have already got the output here in the out. So we have to print the result. For printing, I'll just consider, console log of out dot join. Let's join. As we have made of the split, let's join this one. And we have to read, we have to print line by line. So I'll just give /n over here. So this is fine, I think. So finally, let's call the this one. Let's build the segment tree and process all the queries. So I'll just call here build 0. We'll start from 0 and n minus 1. Also, we have to build the segment tree. Along with it, we have to process all the queries as well, right? Let's call the queries process queries function. Nothing but I have given PROC queries, right? So this one, I'll just call this one over here. So this is it. Let's check whether this works or not. So I'll just come here. So I'll just copy this input. We have to get the output 2, 3 and 1. Let's see whether we'll get this input or not. I mean output or not. So here we are getting something unexpected token read num here. So this has to be just r num in the index. In the number. So here, this, let me run this one again. So here line number 45 for let mod class. Oh, this has to be semicolon, I think. Yeah, line number 45. Somewhere I have typed wrong. Here, yeah, this one I'll just remove the comma and I'll just make this semicolon. Proc queries syntax error, unexpected end of input, where line number 80. So what is the unexpected end of output over here? Console log. This is correct, right? The function name ERIS itself. Yes. Process queries. I have considered this one correctly. Build also, this is fine. What I have done wrong here? Let's check what I have. So here what I have done here is, let's come to line number 49 here. So this one, I have missed one bracket here. So that is the reason this is saying syntax error, unexpected end of input, right? So I have missed one bracket here. So let me add the closing flower bracket here. So let me run this one. So now we are getting the output 2, 3, 1. So we have to get the output 2, 3, 1 itself, right? So yeah, we are correct. We are getting the correct output. Let me copy this one. Just give me a second. So yeah, I'll just come here. Let me click on submit code. So this is problem A itself, right? Queries. So I'll just paste this one. Let me hit the submit button. So let's wait for some time. So this is running, you can clearly see. Let's wait for some time. So yeah, here you can clearly see the code got accepted, right? So code we have written, this works absolutely correct. It's just that I had missed one braces here in the update, I think. Yeah, function update here. I had missed one, this one. So it was saying unexpected, this one, end, right? End of the, this one. So now this works absolutely correct. So I have corrected this one. So this works absolutely correct. And you can clearly see this is accepted. So this is it. Thanks for watching, guys.